Hello, good day to everyone. I welcome you to the another episode on Moldflow's tips and workflow. I have taken a little bit of pause before coming on to this episode, just thinking of what should be the next topic of discussion. And the request was made on by many of the the listeners as well as the users on having a discussion on to some advanced topic. So I thought of putting across the discussion around the part insert molding, which is also sometimes as referred as a you know uh, insert molding of like in metal and the plastic. And also we are going to discuss about the two shot sequential molding as well. Before we get started, I want to get an overview about the what we are going to discuss about it. We're going to discuss about the part insert overmolding analysis options and how to prepare the model, then running the analysis, and also about the result interpretations. Of course, we all would be doing these in using the 3D mesh. Okay, so that's what we would be focusing on. I know there are options to run using the midplane as well, but I would say that's a legacy now. Most of the users now are more comfortable using the 3D mesh. So just an overview of the what is overmolding. It's also referred as a part insert molding. The insert could be the copper insert. It could be even a plastic insert as well. So that's what I would say, copper or metal, any of the inserts. Sorry for that. I just refer a copper, but it could be aluminum, it could be steel, anything on this. And probably you will find most of the common applications into the electrical connectors, parts with the threaded insert, particularly been used for the assemblies and extension cords, which are like the most common example. Probably the computer that which you are using it to review this today's session probably would have the same connector as well. Yeah, and then also like can refer as a two shot sequential molding that we will discuss in detail about that into the later part once we complete uh, the over molding or insert molding. In two shot sequential molding, one part is molded over the another part and then they are made in the same tool. The sequence is that first part is made, the tool is index, and the another to position the in such a way that the another part gets molded. uh, at the same time the another part is also gets molded. Actually, the molding process is thermoplastic over molding at this point of time, and the second shot could be midplane dual domain and the 3D, but today we would be referring only on the 3D part of it. uh, So the insert could be an metal or it could be an plastics. So property used to define the component could be just to you can mesh both the parts and then you can assign that part uh, as a metal or plastic that I'm referring to as an insert. Okay, and mold insert properly used in the cooling to define the part of the mold with different thermal conductivities. Particularly in the what happens in the insert, if it is a plastic, then probably it resists really the heat differentiation. It acts as a resistance to it. And if you are using a like in a copper or aluminum, which would be having a little higher thermal conductivity as compared to the default P20 steel that has been used, so it plays a very crucial role. The property used in the core shift analysis to define the mold component that may move during the filling and packing. We'll not get into the that details or complexity of that one, but at this point of time, just refer that the mold insert, the property used in the cooling to define the part of the mold with different thermal conductivities. It has a very significant impact on to the warpage. Yes, The part without, I just did a comparison between like in a warpage model without insert and the warpage model with the insert. You can see over here, uh, first part without insert, it's showing a bending, and then probably with the insert, it's comparatively a flatten, or I would say the magnitude is much lesser. In this case, if questions are being asked how we define the contacts are completely a bonded contact in this case between the insert and the overmolded part. As I mentioned that it has a different ways to simulate it as well, mid-plane, dual domain, and 3D. But today we would be discussing more onto the 3D part of it. Okay, and if you want to go into the little bit of complexities of it, you can select the user defined orthotropic materials for the inserts as well. That's possible to do that. And as you can see onto the right hand side, it has a much detailed tabulated form of like in terms of defining the local heat transfer coefficient as assuming as a perfect contact or mold surface temperature used for the process setting. And the initial temperature of the insert plays a very crucial role. I have a case study where when one of the customer was trying to create some electrical component which is comprised of the the panel type of thing, which is made of polycarbonates, and one polycarbonate first molded over the another. The initial temperature plays a very crucial role. As we increase the initial temperature, the warpage is reduced. But if the initial temperature is is little lesser, then it has a significant impact onto the warpage as well. The contact time before the injection is something that you can define, that if you want to like preheat or something on that part, you can define that as well. And so you import the assembly, create a 3D mesh of all the components at one time. Different layers for each component automatically gets assigned. Generate the mesh, use the local mesh density as it needed. If you want that some areas you want to be little finer, you can define the local density. But as I said, that there's no need to do that, but it all depends upon you. And when the mesh is created, of course, for the part it would be default 10 layer tetra mesh, and for the inserts it will be a 6 layer tet mesh. This is again optional. I have not seen that many of the users it, but it's also recommended if you want to increase the number of intermediate results. You can go into the advanced settings when you do a fill and pack analysis and the solver parameters, and fill and pack, and then you can change by default from 20 to 25 intermediate results, or you can also specify the intervals for which you want the results to be outputted. Of course, it could be for any analysis, not very specific to the overmolding, but you can do this for any of the normal analysis. But remember that more the iterations that you're going to put or the intermediate results you're going to ask, that much it is going to increase the size of your results as well. So reviewing the results for particularly 3D mesh, you can review throughout the cycle, the plastic part, of course, the part, and of course the insert temperature as well, how it is been varying across the cycle. For example, the mold temperature 60, the mold temperature at the center of the flow channel would be like 260 in this case. That's what it is been shown. And of course we have shown the insert temperature as well. So this is the insert temperature, and then this is the temperature of the polymer at the skin as well as at the intermediate. So this is completely thickness, and this is your inserts that's been running inside the plastic part. We can use the probe XY plot to check in the drop-in, like going through the across that one, it touches to the from the surface to the insert, and it will let you see that how is the temperature of the insert as well, right? And yes, you can use it for the practice purpose as well. If you need this model, reach out to me. Probably I can share this model. But if you have bought the official practice guide from the official training portal from Autodesk, then you should refer the page number 75, PDF page number 91. Okay, that's pretty much on to the overmolding, and or we also refer that as a insert molding. Now let's look into the sequential or the two-shot sequential injection molding part of it. Yes, we are going to look into the rotating plate, which is also referred as a two-shot sequential molding. Let's take an example. For this, you need to run and cool FEM for the two-shot overmolding. You'll get the option as two-shot overmolding. In this case, you can see that there is a first shot and then second shot. This is just the pictorial form of that one which was represented. But if you go a little bit in magnify, let me magnify and show it to you. So this is going to be an actually a first shot at speed model, and then you have to model the second shot as well. Of course, in both the case, you have to model the second shot, the first shot, and then you rotate it. Maybe you have to model a center line over here and then rotate it, and then you can also model the cooling channels as you model in the actual mode. In fact, I would say that you can model the complete core and cavity, and you can see that into how it has been done in detail. So how do you get started on this one? So first you model the first shot, of course, and then it should be a rotating element, because this is going to be a rotated for this one. You need not to make the rotating element for the hot runner also, need not to do. Only for the TET elements you have to rotate, and that's it, and duplicate the part that is going to be rotated out, and then you model the second shot for it actually. So this becomes the green one over here is the second shot. Then you run a cool FEM analysis, and you should be able to see the temperature across the distribution. The warpage will be done for both the shot as we do it for the overmolding. In this case, since both the shots are going to be molded into the single, the indexing happens here. The temperature or the initial temperature or the contact time, you do not to define it. It will be automatically being taken from the analysis actually. So those results probably would remain the same. You will get the two results. First is the result for the normal part, and then bottom of that you will get the results for the overmolding part in this case. So yep. And the one thing that I would recommend looking at is a remelt zone. Yes, you should remember that when you are doing a overmolding or a sequential two-shot overmolding, to have better anchoring of the two parts, you should have a sufficient remelt zone so that the anchoring happens perfectly in this case. That's the purpose of doing the overmolding. Yep, pretty much. Let me show it if I have an example over here to look at that. Not really, but maybe next time I'll show you an example for the sequential or overmolding. If you need more information about this topic, I know this topic are not been regularly used, but these are the specialized process. But if you want more detail about it, reach out to me. I can share those details and some example models. With that, I hope this was useful episode, something different than the usually we do a tips and tricks, but this is also one way of learning a uh, new type of I would not say new, but something different than the usual simulation process. With that, I will talk to you soon again. Take care. Bye.